Welcome to the lesson, Effects of Mixing Hydrogen with Hydrocarbon Fuels. In this lesson, we will look at how mixing hydrogen with other fuels impacts engine performance, fuel storage, and emissions. Let us look at our lesson objectives. By the end of this lesson, you will be able to describe why hydrogen is sometimes mixed with hydrocarbon fuels in internal combustion engines. Next, you will be able to explain how hydrogen affects internal combustion engine performance, including ignition, power, and fuel use. Later, you will be able to identify storage requirements and challenges when mixing hydrogen with other fuels. Then, you will be able to explain how hydrogen blending can reduce emissions in internal combustion engines. Finally, you will be able to describe why hydrogen helps improve lean burn internal combustion engine operation. Let's start by asking this question. Why mix hydrogen with other fuels? Hydrogen can be added to other fuels to make the internal combustion engine run more cleanly and smoothly. It works best with natural gas because both are gases and can be stored in the same type of tank. When hydrogen is added, the internal combustion engine can burn the fuel more easily. This can help lower pollution coming from the internal combustion engine. This is why some companies mix hydrogen with natural gas before using it in the internal combustion engine. Let's look at hydrogen storage rules and challenges. Hydrogen cannot be stored in the same tank as liquid fuels because it will not mix. Hydrogen is very light and would stay above the liquid instead of blending. Additionally, liquid fuels are stored at low pressure, allowing only a small amount of hydrogen to be added. Liquid hydrogen cannot be stored with other fuels because it is extremely cold. If it comes into contact with gasoline, diesel, or other liquid fuels, it will freeze them and create a solid or icy fuel. Because hydrogen must be stored in its own tank, it occupies more space, which can reduce the distance a vehicle can travel before needing to refuel. Let's look at using hydrogen with internal combustion engines. Hydrogen can be used with compact fuels like gasoline, alcohol, or diesel, provided each fuel has its own dedicated tank. Most vehicles using these systems switch between fuels instead of burning both at once. Diesel internal combustion engines cannot ignite hydrogen on their own because hydrogen needs a much higher temperature to start burning. These internal combustion engines would need spark plugs or a small amount of diesel fuel to ignite the hydrogen, but this is not commonly done today. This image depicts a flexible fuel car capable of operating on various types of fuel. The car has separate fuel tanks, steel tanks for gases like hydrogen and natural gas, and regular liquid fuel tanks for ethanol and gasoline. When you want to switch fuels, you simply flip a switch inside the car, and the engine's computer automatically adjusts everything to burn the fuel you're using. All the different fuels travel through special pipes to the engine, where pressure sensors and regulators ensure the gas fuels are at the correct pressure. This system provides drivers with the flexibility to choose their preferred fuel. We'll now look at hethane, which is an example of a fuel blend. Hethane is a fuel mixture composed primarily of natural gas with a small amount of added hydrogen. Internal combustion engines that already use natural gas can run on hethane with no changes needed. This blend helps reduce harmful emissions by more than 20%. If more hydrogen is added to the mix, the internal combustion engine may require some modifications to operate safely and efficiently. This diagram shows how a special material called hethane can capture and store gases underwater. Think of it like making ice cubes, but instead of just freezing water, you're trapping gas bubbles inside. When methane gas from natural gas and hydrogen gas mix with water under cold conditions, they form these white, solid chunks called gas hydrates. They appear to be ice, but contain gas molecules trapped in tiny cages within. You can later break apart these gas hydrates to release the gases when you need them. This is useful because it provides a safe method for storing and transporting gases that are typically difficult to contain. The diagram illustrates the cycle. Gases are absorbed, form solid hydrates, and can then be released back into gases. Let's now look at hydrogen and lean operation. A lean operation means the internal combustion engine uses more air than usual compared to the amount of fuel it burns. This helps reduce harmful emissions. But for hydrocarbon fuels, lean mixtures can be hard to ignite. This can cause misfires, which waste fuel and increase pollution. Hydrogen burns easily and quickly, so adding it helps the mixture ignite better. This reduces misfires and helps the internal combustion engine run smoothly. Hydrogen also helps improve power during lean operation by increasing the energy in the mixture. We will now look at some of the main limitations in the future outlook. Even though hydrogen helps internal combustion engines run more efficiently, storing enough of it remains a challenge because it requires its own tank and occupies space. This means some vehicles may not travel as far before needing more fuel. Car companies are testing hydrogen-powered internal combustion engines to prepare for the future, but these vehicles are not common yet. Until hydrogen stations are built, mixing hydrogen with natural gas is an easier step that still helps reduce emissions. Let's look at the summary for our lesson on the effects of mixing hydrogen with hydrocarbon fuels. Hydrogen helps the internal combustion engine burn fuel more easily. When fuel burns better, the engine runs smoother and produces less pollution. This is why hydrogen is often mixed with natural gas, since both can be stored in the same type of tank. Hydrogen cannot be stored in the same tank as liquid fuels because it will not mix and would simply float above them. Liquid hydrogen also cannot be mixed with other fuels because it is extremely cold and would freeze them. Because hydrogen requires its own tank, it takes up more space and can limit the distance a vehicle can travel. Hydrogen can be used with fuels like gasoline, diesel, or alcohol as long as each fuel has its own tank. Most vehicles burn only one fuel at a time. Diesel engines cannot ignite hydrogen on their own, so they require spark plugs or a small amount of diesel to assist with ignition. However, this method is not commonly used today. Fuel blends like hethane, which contain hydrogen and natural gas, can reduce harmful emissions by more than 20%. Hydrogen also helps lean-burning engines ignite more efficiently, reducing misfires and allowing the engine to run more smoothly. Although storage challenges persist, hydrogen natural gas blends represent a promising transition toward cleaner engines in the future. Thank you.